Hello everyone, welcome to the first video. So the first video was a physics question with stacked boxes with friction. So this is just going to be an example problem with a step-by-step solution. So let's read the problem. Two boxes are sliding together to the right across the table as shown in the figure below. The lower and upper boxes have masses 20 kg and 5 kg respectively. The coefficient of static friction between the two boxes is 0.700. So it's 0.700 here, and the coefficient of kinetic friction between the lower box and the table is 0.300 here. A tension force is applied to the lower box as shown. What is the maximum tension force that can be applied to the lower box so that the two boxes continue to move together? So, static friction is written like this. US of the normal force, right? And so what it means is that static friction is either smaller or equal to mu of static friction, the coefficient of static friction, times the normal force, which means that when they're equal, that's going to be the maximum T that can be applied, or else it will slip off. Because if it's more than that, if it's if the force being applied is greater or if it's greater than the static friction, then they will stop moving together and they'll slip, and the bottom one will keep moving further. So let's draw out the free body diagrams. Here's the free body diagram of the 5 kg one, right? It has static friction as its only horizontal X force being applied, right? So we're going to write that as F of S. It has normal force, and it has its weight pulling down, M1G. Now the 20 kg block, right? It has the normal force of the 5 kg block coming from on top of it, and its own weight. So it's going to be M1G plus M2G, pushing it down, but it has a normal force of N2, balancing it out. It has tension in this direction, but it also has F static and F kinetic because, as it said here, there is kinetic friction between the lower box and the table, which has a coefficient of 0.3. So let's write out our equations. N1 equals mg. We know that. Now F of static friction equals N1 times mu static friction, which equals mu static friction's M1g, which is also the only horizontal force on this block, therefore equating to F of x. Thus, mu s M1g equals M1a, right? Now, let's look at our second diagram. Let's write this in yellow. We have the sum of F of x forces being tension, subtract F of static, subtract F of kinetic. F of kinetic is going to be the coefficient of UK times M1 plus M2, factoring out a G. Subtract the static friction, which we already wrote up, as mu S M1G. Subtract the which all equal due to Newton's second force, second law, sorry, M2A. Now, let's use this one, right? If we just divide M1 and M1, we get A equals mu SG. So, for here, let's substitute A as mu SG. Mu SG M2 equals T subtract mu S M1G subtract mu K M1 plus M2 the whole G. Now, let's move them all onto the same side. We get mu SG M2 plus mu S M1 G plus mu K into M1 plus M2 G, right? Now, mu S is 0.7, so 0.7 times 9.81 times 20 plus 0.75 9.8 plus, now let's distribute these two. Mu K is 0.3, M1 5, 9.8 plus 0.3, 20, 9.8. So let's start grouping some terms together, right? We can see using our algebra skills 0.3 times 20 times 9.8 plus 0.7 times 9.8 times 20 is the same as 9.8 times 20 because 0.3 and 0.7 add up. So 9.8 times 20 is going to be our first term. This is going to be in newtons. Now, we also know 0.7 plus 0.3, again, the same thing with different numbers. It's going to be 1. So it's going to be 5 times 9.8 newtons, which equals 25 into 9.8. Plugging that into our calculator, we get 245 newtons. So the maximum tension in this problem that can be applied to the lower box so that they both continue to move together is 245 newtons. Let's write that down. 5 newtons. Now, if the applied tension exceeds that maximum value, this box will slip and this box will continue going forward. Thank you. Hope you enjoyed the video.